Okay, so for number 319, this is going to be part 2 for us. We're going to continue on here. Page 11, I do believe. There we go. So number 319. After a counterclockwise rotation about point X, the scaling triangle ABC maps onto RST is shown below, which must be true. So remember, ABC maps onto RST. So the order of the letters here is going to match. So A, as we spin around, it does go counterclockwise, going to the left here, but not necessarily going to matter so much as we go around. What it's going to map onto, though, is A is going to go where R is. Okay, B here, as we turn, is going to go where S is. And C, because it's closest to X, is going to go where T is. Okay, so you can kind of get the idea of how everything's going to line up. All right, you can also think about spinning clockwise, just going in this direction, because moving to the left is the same thing as moving to the right. It's just a different number of degrees. All right, so A matching up with R is true. A matching up with S is false. Now, CB, you can see, is stuck in between angles C and B, right? So we already talked about that angle C was equal to T and B was equal to S. So CB should be the same as ST, but it says TR, so that's wrong, okay? And then we know A is not the same as S, and then CA is this side right here. Now C is equal to T and A is equal to R, so it should be equal to TR, but it says TS. So that's why we are going to pick choice number 1. All right, let's go to the right here. 322. Triangle ABC is mapped on the triangle DEF after a line reflection. DEF is mapped on the XYZ after a translation. What is the relationship between, remember, ABC was mapped on the DEF after a reflection, and then we put DEF, all right, onto XYZ with a translation. So remember that if we are doing a reflection and a translation, that's preserving distance, it's preserving angle measure. The only one that doesn't is a dilation. So they are going to be congruent, okay? And if they're congruent, they're also going to be similar. So it should be choice number 1 because all the angles are equal as well. All right. So 2 isn't an option because if you're congruent, you are also similar. 3 is not an option because there's no dilation. Okay. And we know 4 is not going to be true because they are both a translation and a rotation, preserve distance and angle measure. So it's going to be choice number 1. 328. Vertices of JKL have coordinates given. Under which transformation is the image of JKL not congruent? Remember, if it's not congruent, that has to be something to do with a dilation. So we have a translation, okay? We have a rotation, we have a reflection, and here's our dilation. So that's how we know we're going to choose choice 4, okay? Because it has the dilation in it. All right, going back over to the right here, 335. Which transformation would result in the perimeter being different from the perimeter of its image? Remember, reflection, rotation, translation are congruent. So it has to be a dilation. And a dilation always takes some point xy and multiplies it by some scale factor at k, so kx and ky. Now, notice that these have to be the same thing. So we would want to pick one that's 4x and 4y, okay? This first one where we switch x and y around, this would be a reflection. Here we're negating just the y coordinate, okay? This is also a reflection. And this is in the x-axis. This is in the line y equals x. Here we're doing a dilation of 4, centered at the origin. And here we're doing a translation of 2, -5. So these are going to be congruent, and this one won't be because the perimeter is going to change if they're not congruent. All right, let's go just right below here. We'll stay here. So on the left, 342, the diagram below, X, S, and TR intersect at Z. Segments X, Y, and RF are perpendicular, key thing. So that means we're going to get a right angle. all right, when XY hits YR and when RS hits YR, and they form these two triangles, which is always true. Now remember, what else do we know about the triangles? Hopefully you're noticing that we have vertical angles. So therefore, triangle XYZ is similar to triangle. Now X is the same as S, Y is the same as R, and Z is the same as itself. So which is true? We know that they're not necessarily congruent because we don't have any segment lengths that are equal, so we can't get a congruent statement out of this. Now, that also means that we don't know that these segments are equal, okay? But we can make a proportion. So if you make a proportion of XY over SR, okay, that's going from the triangle on the left over the triangle on the right. So we have to be in the same order. So that means that if we choose, and we're just going to switch colors here, XY and SR, then when we pick YZ, we have to pick ZR to be in the same order. Okay, YZ to ZR, and we are going from left to right, so this would be true, and we can select this one. All right, now if you cross multiply this, notice that we would get XY times RZ equals YZ times SR. And this is actually backwards, right? This and this should be switched in order for this to be true. So that's why number 1 is out. And we would pick 4 as our answer. All right, let's go back to the left here, number 336.
336. Go back to the left.
Vertices of the triangle have coordinates that are given, under which transformation is distance and angle measure preserved. So remember, distance and angle measure is going to be either in a translation, okay, a reflection with a lowercase r, or a rotation with a capital R. All right, dilations are out. Now, to be a translation, you have to add something to both the x and the y, okay? So if it's translation, so let me just time out. So it's got to be something with xy becomes x plus a and y plus b, okay? Now, it can be a 0, but it's got to be adding both. So when I look at the first one, I see adding, but this one's multiplying. So that's how I know this is not going to be one I want to pick. I see the same thing on number 3, adding here but multiplying here. So this is also out. And in number 1, I'm multiplying by 2 different things. And remember, that's like a dilation. That's a vertical stretch and a horizontal stretch. So this is also out. So I would want to pick choice 4 because it's preserving distance and angle measure. Now, it also could be something like, another example you might see is something like xy, okay, is going to become, let's say, like x negative y, which is a reflection of the x-axis. This still preserves distance and angle measure, just not orientation. So if that came up, we would not want to pick a reflection. All right, 338. As shown in the diagram below, AB and CD intersect at E, and AC is parallel to BD. Which equation is true? So same thing, we want to pair up our angles. So notice that if the lines are parallel, they're going to make our Z's here. So DA is going to be the same as B, okay? D is going to be the same as C, and we have the vertical angles at E, which are equal. So if you have colors, you're allowed to take colored pencils into the exam, okay, or different colored pens. So we know that AC and DB line up, that AE and it's got to be in between the one arc. Sorry, yeah. Wait, we did this one wrong. This angle we just marked wrong. This should have one arc on it, not 2. So between the 1 and 3, this side, AE corresponds to EB, and then DE corresponds to EC. So look at how these are labeled. CE over ED. This is the top, right, the top triangle. We'll call it the big triangle. How about that? This is the big triangle over the small triangle, the little triangle. EB over EA, this is the small over the big. These are in the opposite order, so we don't want to pick this one. This is not in the same order. Okay, go to the next one, AE over EB. So once again, this is big over small. AC over BD is also big over small, and we're comparing blue, right, to blue, and then red to red. So this one would work. This would work, okay? If we look at the next one, let's see why this doesn't work. EC over EA. Now notice, we're doing the big triangle, but we're doing, let's say, purple over blue. And in the bottom triangle, we're doing BE to ED, which is red over purple. And you can see that these sides aren't corresponding. They're not the same colors. They're not in the same spots. That's why we're not picking number 3. Number 4, ED, purple, over EC, purple, but it's going from small to big. And then AC over BD is going from big to small. So these, once again, are not in the same order, and that's why we're not picking them. So choice 2 is correct because they're the same corresponding sides, the same colors that we labeled, and they're going from the same triangle, big triangle, to the small triangle for both. Make sure you're consistent in your proportions. All right, 346. We got ourselves a triangle below. Now, this question is a little difficult. I'm going to do it wrong first. We'll talk about why, and then we'll do it correctly. Okay, so we're going to read. We're going to label. Always do that first. So we got T and O are S and U and CU respectively. OT is drawn, so angle C and angle OTU are congruent. So let's go mark it. Okay, C and OTU, where T is. Those are equal. Okay, TU is 4, OU is 5, OC is 7. What is ST? So we can call ST X here, okay? So TU is 4, OU is 5, OC is 7, and we're trying to find the length of ST, which is X. Now, the incorrect way to do it, incorrect. All right? We're going to do this off to the side over here so it's not in the question. We left the I off of incorrect. All right, incorrect way to do it is to go top to bottom here. And the reason we can do a proportion is because angle U is equal to itself. We have a little reflection. So we have angle to get the triangles congruent. Now, if you do X over 4 from this side and then try to do 7 over 5, this is incorrect. This is not true, okay? The reason why is let's write out our similarity statement, okay? So triangle C, U, S. Now, C is the same as T. So this has to be T, U, O. So notice that we did ST, right? ST here, okay? And what we're going to notice is that these sides don't actually line up this way, right? CU does not correspond to OU, right? It corresponds to TU up here. It actually corresponds to this side, okay? And then OT still corresponds to CS, all right? But SU corresponds to OU. So this triangle here is actually upside down. It's not the correct way because these two lines aren't parallel. In order for me to do top to bottom, it has to be a side splitter theorem, and these two sides have to be parallel, but they're not. It doesn't tell me they're parallel. So what I really need to do is redraw the bottom triangle here, okay, so that U is here, T is here, and O is here. So now I know that this is in the same order. And therefore, this is 4, right? UT is 4, and OU is 5. Now I can go and compare and solve for the sides in my triangles, okay? What I need to do is compare the two triangles and know that this side is 12, and this side is x plus 4. So now we can go solve. And I can say that x plus 4, the top side in the big triangle over the top side in the small triangle, which is 5, is equal to 12 over 4. And then we can cross multiply and solve. So 4x plus 16 is equal to 60. We'll minus the 16 from both sides. We get 4x is equal to 44. and then divide by 4 to get x is equal to 11. And since we called x st, that is our answer, and we should pick choice 3. Okay, so the big one here is we can't do top to bottom unless we have a side splitter and these two sides are parallel. Otherwise, you got to match up your angles, so make sure we're drawing so that they're in the same position, and then we can cross multiply and solve. Okay, 351, to find the distance across the pond. Now, as you notice in this one, we have our triangles drawn. We want to figure out the distance from point B to C to the nearest yard. And these are all in yards, so we don't have to do any conversions. But because we have right angles here, that means that these two lines are parallel. So we already have the triangles drawn so that they're in this, the way they're laid out, the corresponding sides are in the same position. So AD corresponds to AB, DE corresponds to BC, and then AE corresponds to AC. So we can just figure out the length of BC. We can just make a proportion, but we have to use the big side here. We have to know the whole thing. So you cannot do 230 over 85 equals 120 over x. This is not going to work, okay? Or even if you flip it and make it x over 120, so it's bigger or smaller, this still doesn't work. Okay, and the reason why is 230 is not the entire length of the whole side, the big triangle. So we want to set up a ratio of big triangle over the small triangle. All right, and 230 plus 85 is going to be equal 315. Okay, and so that is what I'm going to use for my proportion. So we're going to do 315, the bottom, big side, over the small, which is 230, is equal to the big triangle, which is x, over 120. And now we're going to cross multiply and solve. So 230x is equal to, multiply times 120, we get 37,800, and we divide by 230 to get the final answer, which is equal to, and it says to the nearest yard, x is equal to, when we divide it out, we get 164.3478261. So when we round it to the nearest yard, we get 164 yards. That is our answer. Okay, so careful on when you're doing those ones. That's how we're going to make sure we get it done. So big triangle, small triangle, or top to bottom. All right, 357. We did this one in class, but we'll go over it again. So anytime we have a right triangle, okay, and we draw the altitude to the hypotenuse, this is how you're going to recognize that you're doing these questions, this statement. What happens is we're taking a right triangle that's already there, and we're creating two new right triangles that are both similar to the original. So all we need to do is draw the three triangles that look the same in the same position, label the sides that we're given, or we might be able to find extra pieces from our information, create a proportion using the segments that are in the same spots, and then cross multiply and solve. That's it. Easier said than done, I know, but here we go. So 357. Once again, we have the altitude drawn to RT, which is the hypotenuse. So we started with a right triangle, okay? We know that because it talked about the fact that altitude SU is drawn and that RST was a right triangle. Okay, now because we made an altitude, this is automatically going to become a right angle down here at U. So we're going to draw three triangles that look like RST here. Okay, we're going to draw a big triangle with a right angle up top. We're going to draw a little smaller version of that with a right angle still up top. And then we're going to draw a little smaller version of that with still the right angle in the same spot. Now we can label the sides. In the original triangle, this was S because that's where the right angle is. R is the longer leg, and then T is the shorter leg. Now the right angle in the smaller triangles is both of these are at U, okay? And then in the triangle on the left, which is the medium one, it goes from U to R or U to S. And U to R is longer, so R goes here and S goes here. And in the small triangle, it goes U to T or U to S, and S is longer, so S is going to go there and T goes here. Okay, so now we just label. We know SU is H, We know UT is 12 and RT is 42. So we have SU is H, so that goes here. I'm going to label this in red just so we have a different color. And here, okay. UT is 12. So there's a UT right here, that's 12. That's the only UT we have. And that means this whole segment, RT, is 42. Now, because this is the whole segment is 42, and this is 12, that makes RU 30, so we get a total of 42. So this side gets 42, and RU, which is underneath, gets 30. Now, in the big triangle, we only have one side of 42. In the medium-sized triangle, right, we have sides of 30 and H, which are the two legs. And the small triangles, we have sides of H and 12, which are also the legs. So notice that these four sides are in the same corresponding parts. They're in the same area, right? 30 corresponds to H, okay? And then this H, which is US, corresponds to 12, which is UT. And now we can make a proportion, okay? So we can go from big to small. We can go from left to right. But either way, we're going to do 30 over H, 30 over H, and that means H over 12. And then we just cross multiply and solve. So 12 times 3 is 360 is equal to H squared. And then all we're going to do now is take the square root. Now, you may remember on the calculator, okay, new document, not going to save, that we can do on the calculator page menu and then 2, 3 factor. We can type in our number and it will give us the prime factors. So there's 3 2s, 2 3s, and a 5. So, and if you really need to, you can always multiply to get the number we need. So 3 2s, 2 3s, and a 5. And then remember, we circle our sets. So we have our 2 2s, we have 2 3s. So we're going to pull one number from each of those out. So there's going to be a 2 and a 3 in the front, which makes 6, okay? That's our coefficient, the square root, and 2 times 5 inside, so that's 10. And so we know that this is going to be our answer because it simplifies correctly. Now, we can check that, or if you forget how to do this, you can just type in the square root, okay, of 360, hit enter, and get the decimal, and then you can type in each of the answers until you get the same decimal. Now, if you end up getting, let's say we did 2 square root of 90, right? You'll get the same decimal, but notice that we always want to pick the number with the smaller number inside. So if you have 2 that are the same, pick the one with the smaller number inside the radical. That's how it, it's simplified. All right, let's go to 358. Okay, so in 358, we have the same thing. We have an altitude drawn to the hypotenuse again, so we know that we're doing our 3 triangles. We have BD, which is 4. We have AD, which is x minus 6, and CD is x. What is the length of CD? So once again, we have our right angle at the top, we have our 2 smaller right angles at the bottom, and now we're going to go ahead and draw out our 3 triangles. So there's the big, there's the medium, and there's our small guy. Okay, so this is A, B, C. The right angle for the medium side is at D. The short leg is either B to D or D to C, so B goes here, C goes there. D is once again the right angle here, and it goes from D to A and D to B. So A is shorter, it's going to go there, and then we label. So AD on the small triangle is x minus 6. So that's going to go here. And I'm going to switch colors just so we can see these a little bit better. So this is going to be x minus 6. The longer leg DB here is 4. In the medium-sized triangle over here, BD is 4 and CD is x. And in the really big triangle, the only thing I know is that this entire side is x plus x minus 6. That's 2x minus 6. That's all I have here. I don't have any other matching hypotenuses, so we can ignore this. So notice that we have 4 and x minus 6 that correspond here, okay? And then we also have x and the 4 here that correspond. So we can go ahead and make a proportion with those sides. So we can say that 4 over x minus 6 is equal to x over 4. And then we can cross multiply. 4 times 4 is 16. X times x minus 6 is x squared minus 6x. Remember, we're going to distribute through when we multiply. And because we're recognizing this x squared, oh no, that means it has to be a quadratic. So remember, we need to get this thing equal to 0 first. So we're going to need to move that 16 over to the other side by subtracting. So x squared minus 6x minus 16. And at this point, we can pull out our diamond here. We need two numbers that multiply to 16. That's the number on the end. And add or subtract to give us negative 6. And hopefully, you're catching on that it's got to be 8 and 2 with a negative 8 and a positive 2 to make negative 6. And so I'm going to go put my factored form. So that's where I insert the x minus 8 and the x plus 2. And then I'm going to solve. So if x minus 8 is equal to 0, that means x is equal to 8. And if x plus 2 is equal to 0, we can subtract the 2 here and get x is equal to negative 2. And this is an or in here, so this is exactly how we're solving. Now, because it wants to know the length of CD, and we called CD x, right? That means we just plug x in, and we get an answer of 8. Always double check that what you're solving for is what your variable is. All right, two more. 434, Christy is testing values that would make the triangle drawn a right triangle when Ln is the altitude. So remember, we're going to just go ahead and say that we want to know it's going to right triangle, so we're going to call these angles 90 degrees. We're going to place these sides in and see if they work, okay? Now, we're going to draw out our 3 different triangles. So there's the big triangle, medium-sized triangle, mini-me, okay? So, label our sides. All right, time out, people. This is not even close because we have AD and DB. So you know what? These are switched. All right, these answers over here need to go and switch up over here, okay? So these choices are actually for 433, and these are for 434. Okay, so let's try these ones together. Let's try this again. Okay, so if Km is 16, which is on the bottom, all right, we're going to go through and do this. So now remember, we can label our sides. This is L, K, and M. The right angle is at N. It's N to K. No, it's not. It's N to L. And L, N to M. And then at N, it's N to K or N to L. Okay. So we know this is 16. If AD, switch it up. So what I'm going to do, real quick, give me a second. All right, we just cut and paste it up so they're switched up here. So if LM is 13 and KN is 6, okay, does this work? So now remember, we're going to go over to the triangles. Okay, we're going to label this as 13, and that means this side is 13 because this is also LM. And then if Kn is 6, that means that Nm is 10. And so we can label Kn, right? So where's Kn? Here's 6. Okay. And then Nm is going to be 10. And now we can see that we do have some numbers that are in the same spots. So that means if we create a proportion and we cross multiply, it should work. Okay. So for choice number 1, our proportion would be 13 over 10 is equal to 13 over 10 would be 16 over 13. Now, if we cross multiply, right, we're going to get 160 is equal to 169, and these are not equal, so choice 1 is out. Okay, you see how that works? Now we got to go try choice 2. All right, so we're going to just drop these out here, and we'll switch colors. All right, I'm going to erase them because I have the ability, If I were doing this on the test, you'll have more room than this. It is a lot of work for a multiple choice question, but hopefully you get the idea. All right, if LM is 12, okay, so now we're at 12 here. All right, then that is this side down here as well. And then we have NM is 9. That leaves this to be 7. So once again, we can label. So KN is 7. NM is 9. Okay, so we just have 7 in this triangle. In the triangle over here, we have 9 and 12 for the hypotenuse. And then in this triangle, we have 12 and 9. So do you see how we have KM, by the way, we forgot to label this. This was already given to us as 16. I'm going to label this in black because this isn't going to change. So we have 12 and 16, 9 and 12. And now we can go ahead and separate proportion. You can already kind of tell that hopefully that you can kind of see that this is not going to work. So number 2, 12 over 9 equals 16 over 12. So 12 times 12 is 144. Ooh, it is going to work, people. 12 times 12 is 144. And 9 times 16 is also 144. And since this does work, they're equal. This is proportional. And that's my answer. Okay, so you just want to label your sides, pick your proportion, see which one is going to give you that answer when we're done. Okay. For number 433, same question, altitude to the hypotenuse. Now, it says which of these will not produce an altitude that is 6 radical 2? The altitude is this side, so we can just call that x. Now, 6 radical 2 is 8.48528137.4. So we just need to get this decimal as an answer. Okay? So if AD is 2 and DB is 36, hopefully you can kind of see in the triangles without having to draw the 3 triangles out. You're more than welcome to. That's how we've been doing it. So we'll do it again just to keep comfort level with this. But it's going to be short leg over long leg and then short leg over long leg. So we're going to get like the same thing every time. You kind of get the idea here. So once again, we have C, A, and B. Now our right angle is here at D. The short leg going out is D to A, and then D to C. Oh, that's the small triangle. This should be D to C and D to B, and then from D to A and D to C. Okay, so let's do it. We can now label. So we know that this side is X all day, where CD is. This is going to be X, okay? So if we call this side 2 and this side 36, that's AD is 2 and DB is 36. So we're just going to take these out, in and out all day. That means I'm going to do X over 2 and then 36 over X. So the numbers you take in and out are just going to get put in that spot, basically. So for choice number 1, X over 2 equals 36 over X. We cross multiply, we get X squared is equal to 72. And then when we take the square root of 72, let's make sure we get that same decimal. Okay? And guess what? We do. This is equal to 6 radical 2 because it's equal to that crazy decimal. Now remember, it said which of these would not produce. So this does produce, so we don't want to pick it. Okay, so what if we called AD instead of 2? What if we called this 3? And we said that AB was 24. That would make this 21. So we're going to swap out the 2 for 3 and the 36 for 21, and let's try it again. So X over 3 equals 21 over X. You can see how we're just taking out the numbers and just plugging in. So we get X squared is equal to 63. We take the square root of this. Let's see if we get that same decimal. We don't. We get 7.93725, not the same. So this is going to be our answer. Okay. And that is it for tonight. And we'll see you guys tomorrow. Have a great day.
Bye.